Good evening, everyone. This is the third video in the lecture series of particle physics. So, in this video, we will discuss about quarks, okay, and quark bound states. So, there are some particles which are made of quarks, and how they are made of quarks we will see in this video. So, there are baryons, okay, and mesons, which are made of quarks. Okay, you can ask me the question, why not fermions? Why not fermions are made of quarks? Because why? Fermions and leptons, why they are not made of quarks? Sorry, not fermions. Oh, leptons. Why not leptons made of quarks? Why? Because leptons are themselves fundamental particles, right? Leptons are fundamental particles, okay? And leptons or quarks are the most fundamental particles we are studied in the previous lecture. So leptons cannot be made of quarks, okay? All right. So leptons cannot be made of quarks. So baryons and mesons. Baryons and mesons should be made of quark. So how they are made of quarks? See, baryons are a bound state means simply made of three quarks. Baryons are made of three quarks, right? So we can say what we can say in the sentence: baryon is a baryon is a three bound quark, three quark bound state, three quark bound state, three quark bound state. Okay, that means it's made of three quarks. All right. Now mesons are also there. Mesons are what? Mesons are one quark and another anti-quark. Okay, mesons are made of one quark and another anti-quark. All right. So what are the quarks we have studied? What are the quarks? Up, down. Okay, charm, strange, and top, bottom. These are the but different flavors of quark. We call it what? Flavors. Whereas these UCT, op, charm, and top have 2 by 3 electronic charge plus 2 by 3, and D, down, strange, and bottom have minus 1 by 3 electronic charge. Alright. Hmm. Yeah. For example, let's see. Let's apply this. For example, proton. Okay. What is the charge of proton? E, electron. What is the charge of proton? This one. So I can write it as what? I can write it as plus 2 by 3 E plus 2 by 3 E plus 2 by 3 E minus 1 by 3. Then only I can say that this is your E, because this is 4. Okay, if I take the LCM as 3, this is 2 plus 2 minus 1, that is 4 minus 1, that is 3. So 3 by 3 E is how much? E. So this is the structure of proton, that is, this is what? 2 by 3 is what? Up, 2 by 3 is up, and minus 1 by 3 is down. So you can say up, up, and down. Alright? Yeah. Up, and down. UUD is the quark structure. We can say quark structure of proton is what? Question may come. Quark structure. Quark structure of proton is quark structure of proton is UUD. UUD. Okay. Next is, for example, neutron. Proton is a what? Proton is a baryon. So see, baryon we got as QQQ, means three quarks, right? Proton is a baryon. Which type of baryon? It's a nucleon. Okay, say what? Nucleon. Slowly we are going into that category thing like standard model. Okay, we will go to that slowly. We will not just directly write all the categories. So proton is a nucleon which is a baryon. Okay. So next another nucleon is what? What do you mean by nucleon? Something that resides inside the nucleus. Okay, like a part of nucleus. Something that is the inside the nucleus. That is a nucleon. So except proton, what is inside nucleon? Nucleus. What is inside nucleus except proton? That is neutron, right? Proton and neutron make up nucleus. So neutron is what? What is the charge of neutron? Zero, right? Charge of neutron is zero, isn't it? Charge of neutron is zero. Then what will be its quark structure? I can write it as plus 2 by 3e. This one you have to figure out on your own. Like minus 1 by 3e. You have to figure out all the possibilities and then you will find that this is plus 2 by e minus 1 by 3 minus 1 by 3. So this is a what? 2 minus 1 minus 1 whole divided by 3 into e. So this will make up your 0, isn't it? This is your what? 0. Charge is 0. So we will write the structure. This is your u, this is u, this is d, and this is d. Okay, u, d, d is the quark structure of what? Neutron. Okay. Again, neutron seek. Neutron is a baryon, and we got it as quark structure. All right. Hmm. So we got a what? What will I say? Nucleon. Yesterday we studied about leptons. Okay, classification of leptons. Today we'll slowly go into baryons. Nucleon is what? Proton and neutron. Proton and neutron. Proton is UUD. Neutron is UDT. You may ask me the question, why it's UUD? It can be CCS, isn't it? CSS. Hmm? Why not like that? If I take CCS, but S is what? S is a strangeness quantum, like quark, strange quark. But see, proton doesn't have strangeness. Strangeness is a property of particles, right? Strangeness, but proton has strangeness 0. That's why there will be no S. All right. Neutron also doesn't have strangeness, so that won't have S. There is another reason why we cannot use charm. So you, this is a homework. This is a homework is why don't we use charm or even TTB? Why not TTB? Because they have the same kind of, right. Why not TTB? Why UUD? Okay, so this is your homework. Why UUD, not TTB, not TTB, not CCS. Protons structure. Okay, why? Okay. Yeah. So this is a nucleons are protons and neutrons are nucleons. UUD, UDD. Right? Hmm. And mesons. Okay, what are mesons? But this is only one type of baryon. There are more baryons there. I will tell you. Mesons. Otherwise, let's finish baryons first. Okay, this is nucleons. There are more baryons. What are those baryons? See, baryons. What are the baryons are there? These are called Right. There is another type of baryon. Wait, let me do it a bit properly. If I baryons, so one is your nucleons, okay. Another is your called hyperons, okay. So we are slowly moving towards that, okay. Hyperons. Now we will divide. We have already divided nucleons as what? Neutron and proton. Now what are hyperons? See hyperons. Hyperons. Okay. What are hyperons? We'll see one by one. One is your sigma. Okay. Sigma plus, sigma 0, sigma minus. This is what sigma. Then comes your cascade. Cascade minus and cascade 0. Cascade 0. This is called your cascade. Okay. Next comes your lambda. This is only lambda 0. Lambda. Omega. Omega minus. Okay. Alright. Omega minus. There is also this delta. Delta plus plus. Delta has four particles. Delta plus plus. Delta plus. Delta naught and delta minus. Okay. These are called resonance particles. We will study that later. This comes under resonance particles. This comes under what? Resonance particles. Right. So if we see sigma plus, its charge is what? Charge is what? Plus means plus 1 E, isn't it? Plus E. Okay. So you have to tell me it's what quark structure. Okay. Do the quark structure yourself. Sigma naught, then sigma minus. Okay. Then this one cascade minus. These are baryons, isn't it? These are baryons. So baryons quark structure is what? Three quarks. Okay. So try to do it. All right. Three quarks. All right. Now, mm, okay. So mesons, for example, mesons are there. Mesons. Mesons are what? Pi mesons, pi plus, pi naught, pi 0, and pi minus. Okay. Pi plus, pi 0, pi minus. Then chions, chi, k plus, and k 0. And their antiparticles there. I'll leave it. This for later. Rho mesons are there. Rho plus, rho 0. These are the resonance particles of mesons. Rho minus. Okay. So their quark structure will be like what? Pi plus will be what? This is a meson, so Q bar or Q dash. That means one particle, one quark, one antiquark. So for example, this is plus 1 E, na? Plus 1 E. So one is U, another D bar. Can I write like this? Just check. U is what? U is plus 2 by 3 E. Okay. D is actually what? Minus 1 by 3 E. D is this, but this is what? This is antiparticle of downward. So I have to write it as plus. Okay. Yeah. So this is 3 by 3, that is E, which is what? This one. Alright, exactly like that. Pi minus. Pi minus, can I write like this? Du bar, isn't it? Du bar. D is what? Minus 1 by 3 E. This is your what? Minus. U is actually what? Plus 2 by 3 E. But this is an anti-quark of U. So this is anti-quark, that is minus 1 by 2 by 3. So this is minus E. Right? This is pi minus minus. Okay. So this is the concept. This is the quark structure. Okay. Du bar, ud bar. You can also calculate for pi 0. You can also calculate for k plus, k minus. Okay, k 0, k plus. Okay, this one be careful. K plus. Okay, k plus is a strange particle. Strange. Okay. Okay, wait. I have done a mistake here. Just wait. I will tell you. Okay, all the write down a point. All the kaons and hyperons. All the kaons and hyperons. All the kaons and hyperons are strange particles. Okay, are strange particles. Why they are called strange particles? They are formed by strong interaction, but they decay by weak interaction. That's why they're called strange particles. Okay, so all the kaons and hyperons are called strange particles. So kaons means what? The K plus and K zero, and hyperons means what? Everything, those sigma and cascade and all. Okay, sigma, omega, lambda, cascade. Hmm, okay, yeah. But one thing, this one. Wait, this is not your hyperon. Okay, my bad. This is not a hyperon. This doesn't have strangeness. Okay, yeah. So yeah, like kaons and hyperons are strange particles. So kaons I can write as K plus. So K plus strangeness is what? Strangeness is plus one. Okay. With the strangeness things we'll study later. Okay. Strangeness is plus one. And the antiparticle of K plus is what? K minus. Is strangeness will be what? Minus one. Okay. So strangeness is something we'll go for later. Okay. Yeah. So this is your this is what? This is your quark structure. Alright. Otherwise let me finish it here only. Strangeness, like you can say K plus is how much? K plus strangeness is, yes, is plus one. K naught also strangeness plus one. All the hyperons like sigma and all, sigma has strangeness minus one. Cascade has strangeness what? Minus two. Okay, lambda has strangeness minus one. Omega has strangeness minus three. Right? Omega has strangeness minus three. So these are the particles, these are the strangeness you need to remember. Okay. Another thing, omega minus is not an antiparticle of omega plus. Okay. Don't think like that. Otherwise, omega, I'm saying sigma minus is not the antiparticle of sigma plus. Okay. Yeah. Remember these points. Otherwise, their strangeness will be different. So this is a strangeness through which you can make the quark structure. For example, K plus. Strangeness is plus one, right? So strange quark has what? Charge is minus 1 by 3 E. Alright. So Q dash if I write, so Q will be what? U. This one will be U dash, U S dash, isn't it? Because U is what? Plus 2 by 3 E. U is your plus 2 by 3 E. S dash is what? Minus 1 by 3 E. That S dash will be plus 1 by 3. It's plus 1 by 3 E. So this one will become what? E, which is your plus 1. Okay, right? K naught, K naught, Q dash again. Can I write like this? S, S, D, S, D dash, or T, S dash. Can I write like this? Because see, S is what? Minus 1 by 3 E. D is minus 1 by 3, but D dash will be what? Plus 1 by 3. So they cancel each other out and that will be 0. Okay. Exactly D S dash is also you can check that will be 0, which is this one. Okay. So this is your quark structure. You can also calculate for sigma plus, sigma minus, sigma 0. This is a homework. Okay. I won't be solving everything. You should be able to do all those things. This one, all this. Okay. Calculate there what? Quark structure. Quark structure. Alright. Yeah. So this is your quark structure. Okay, now okay, masses of these particles actually vary quite widely. Okay, and they appear to have no pattern. Actually, there is no pattern for determining the mass. It's generally believed that actually the masses of all elementary particles are acquired through some symmetry breaking effect. Okay, with a field called Higgs field. Symmetry breaking effect with a field called what? Higgs field. With a field called Higgs field. All right. So the basic idea is actually the Higgs field. What the Higgs field causes a kind of drag, okay, on all the elementary particles. Okay, causes a drag, like it pulls back, and this drag is what we perceive as what? Inertial mass. Okay, inertial. Sorry, this drag is something we call as inertial mass. Okay, yeah, inertial mass. Okay, and a consequence of this idea is that what? There must exist at least one spin zero boson. Okay, and which is called actually what? Higgs particle. So Higgs particle is a what? Spin zero. These things are like where it is all performed mainly at CERN, okay, which is in Switzerland. Particle accelerator is there. So, CERN. You can read more about CERN, which is in Switzerland. Okay. So this is much about quarks and all. Quarks, strangeness, strange particles, hyperons, kaons, mesons, all these things. Okay, so what have we studied so far? We have studied so far about leptons. Okay, leptons, and now today we studied about baryons. Okay, baryons and nucleons and hyperons, isn't it? Nucleons and hyperons. Hmm. Yeah, leptons are there. Okay, and there are also mesons, isn't it? Mesons are there. Yeah. So these are some of the types of particle that we will come across in this particle physics. Okay, right? Got it. Yeah. If you have any doubt, you can give me the like keep comment in the comment section. Right? Yeah. So yeah, that'll be it for this video, and we'll discuss more things about this classification and all in the next video.